Hi, class. Let's get into some math operations in C++. The math operators are exactly as you might expect. Plus is our math operator for addition. Minus, of course, for subtraction. And you may have experience before with the asterisk, but we do use that in computer science for multiplication. And then the forward slash is going to be our division. Now, in the next module or two, we'll look at a couple more math operators, specifically the modulus operator, and we'll also talk about a condition called integer division. But for right now, we'll put those aside until next module or so. Now, math operations are just pretty straightforward, like we would do in our high school algebra class. Our order of operations is the same as algebra. We start working left to right, and the same hierarchy of operations applies. So that means if we had A plus B times C, the hierarchy of operations says that multiplication and division will get executed before addition and subtraction. So in this math expression right here, this B times C gets executed first. And then this addition, A plus B, gets executed second. So this really becomes, if we were to kind of list the order here, A plus B times C, and this is reduced first, and that result then is sent down to here for that expression, and then we have this expression executed, and that returns a value. So remember those order of operations. The same hierarchy applies. Now in our work coding, we'll use the exact same syntax as we normally would. If you want to force a different order of operations, then we just use parentheses, just like we did in algebra. So let's say that we're coding now, and these are just regular C++ statements. We could easily say, let's suppose we've got a couple of variables already declared. Just like that. And keep in mind, and I've gone over this in the variables video, keep in mind that there are multiple ways to both declare and then initialize or assign a value to a variable. And here I'm using the combined declaration and initialization, and also the combined, the multiple combination techniques. So suppose we have these three values. If we wanted to add them up, then we could easily do that. We would just use an expression. So a math expression is really going to be anything that would belong to the right of the equal sign. So for example, value 1 plus value 2 plus value 3. That in and of itself is a math expression. No equal sign, no nothing. It's just a sequence of tokens that need to be reduced, either through math operators or through some other function executions. So this is what's called a math expression. And given a math expression, we can do a couple of things. We can either output it, or we can assign it to another variable. So what do I mean by outputting it? Well, presuming that we've got this code here in line 1 and line 2, let's say, If we then had a line 3 that said this, count, and then we put an expression in here, and I'll shorten that expression just for this demo purpose. We see that this count statement, it contains not a variable to be output and not a, say, a string or a character, no other literals. Instead, it's outputting a math expression. So this is going to get reduced first, and whatever result is returned from that, that is what gets actually output. So that's one way to do a math expression using a variety of math operators and having the output displayed to the console. However, the second method is going to be a lot more common and probably a lot more important, because it usually is the situation where we need to store the result of a math expression in another variable. So what do I mean by that? Well, here, we had this math expression, and if we wanted to store what gets returned from that, then we could just do this, int sum equals, and then whatever gets returned from there is going to then get assigned to sum. Keep in mind, we can also do it splitting the declaration and assignment. So we could do this, int sum, and that just declares it. And then we could do an assignment, sum equals value 1 plus value 2. And then at this point, we could count sum. And I'll always do an end line there as a matter of practice, just to make sure we always get the return character in. So this is the second way, where rather than we're counting an expression here, we're actually counting a variable, and that variable's contents, of course. So let's take a look at some examples of math expressions that might be, slightly more complex than just an addition operator. Let's say that we needed to figure out how much tax is going to be charged on an item. Well, let's say we had then double item price. This creates a variable called item price of type double. And let's say that that's $32.95. Well, let's suppose that tax on that is going to be 8%. So how can we calculate the tax and the total? Well, we could do it two ways. One is that we'll separately calculate the tax. So we'll first create that variable tax, and then we'll do an assignment to figure out, well, how much is it? So tax then equals item price and then times an appropriate tax rate. And let's say it's 8%. Then we can multiply this by 0.08. And then given that, we could certainly calculate the total. And that's going to equal the item price, of course, plus the tax. So that's one way to do it, is to kind of calculate all of these independently. Of course, we could tighten up our code a little bit here by combining these two lines. We could also tighten up our code a little bit by combining these two lines. Now, the other way, though, is a way to immediately calculate the total would be just to multiply by 1.08. So you could say total equals item price times 1.08. And that'll get us the same result total. The only disadvantage with the solution on the right side is that we didn't store the amount of tax as a separate variable. And that may be fine. Maybe we don't need to calculate and store it for the rest of the program. If we did, then the prudent thing to do is, well, let's store it in a variable. But in this case, if you just need something one time real quick, then this would be an easy way to do it. Just calculate it with 1.08. So let's see, that's one example here of a couple of different math operators. Look, another one would be, well, let's see, how we could average something, okay? Now let's see. I think I'll do doubles instead. There's A, B, and C, all doubles. And please watch the variables video if this string of writing does not make sense to you. All we're doing is declaring three variables, A, B, and C, and we're providing initialization values to each of them. So if we wanted to calculate an average, well, we've got to somehow figure out the sum of A plus B plus C, and then divide that by the number of items that are in the numerator, in this case, 3. So we all understand that, and we remember that from our earlier math experiences. How do we convert this into code that our computer is going to understand? Well, we could certainly do it this way: A plus B plus C divided by 3. But I think you know already that this will cause some unexpected behavior. And that's because the order of operations is going to demand that this division sign is executed first, and then this addition sign second, and finally this addition sign. And that's not what we want. So we need to force an early compilation of that addition operation. And we can just do that with parentheses. So we'll add a parenthesis here and a parenthesis here. Well, that is actually literally what the code is going to be for C++. And of course, let's assign that to a proper variable called, how about average? And that could look like this then: double average equals parenthesis A plus B plus C divided by 3. Then with that average stored in the variable average, we can then go and we can output that. We could use that as part of a math expression. That would look like this: double, how about a variable called triple average, where we're just going to take the average and triple it. Well, that math expression is going to be then quite easy. We've already calculated average here, so we can leverage that and use that right here and at any subsequent point in our code, since that's been declared. So this is a little bit more complex math operators that can be used to form more complex math expressions. And we'll have a few more of these types of exercises and labs in coming modules, just to make sure that we stay on top of this. So hope this helps with our first start at math expressions. And as always, please hop on the discussion board if you've got any question about any of this content. All right, thanks everybody.